So welcome everybody to the seminar today, the MIDAS seminar with Christo Wilson. We're delighted that he's here. He's an associate professor at Northeastern University in the Khoury School of Computer Science. Christo got his bachelor's, master's, and PhD degree from the University of California in Santa Barbara. And he has been a real leader at the intersection of big data with security and privacy, and particularly with auditing black box systems. So you're on the web and there's somebody doing something and you don't have access to what it is that they're doing internally, but you can see what you can see. There are limits to what you can find out. And Christo's been working hard to push those limits and is going to tell us a little bit about some of his recent work in that direction, is what I understand. He is a Sloan Fellow. He's a fellow at the Berkman Klein Center for Internet and Society. He has received any number of awards, including best papers at SIGCOMM, at NDSS, at ICWSM, and on and on. So really delighted to have you here, Christo. Really looking forward to your talk. Before I turn this over to you, I'd just like to remind everybody that next week is the MIDAS annual symposium on the 10th and 11th. And because of that, there will be no Monday afternoon seminar on the 9th. I urge all of you to participate in the annual symposium. We have talks by the Chief Scientific Officer of Microsoft, Eric Horvitz, and we have a talk on data feminism, and a number of talks by various researchers talking more about their vision than about the results. That was sort of the understanding that we had with the speakers. So do tune in. You can see the detailed program by going to the MIDAS website and going to the events tab for the annual symposium. Our regular seminar series then continues beginning the following week. On the 16th, we have Paul Bennett from Microsoft. And on the 23rd, we have our own Stuart Soroka. I'd finally like to thank all of the sponsors and affiliates who are listed on this slide. We greatly appreciate their support. And with that, I'd like to turn it over to you, Christo. Looking forward to hearing your talk.
Well, thank you very much. And I'm super happy to be here. The symposium sounds very interesting as well. I just started reading Data Feminism, and it is excellent. Let's switch into here. Yeah, so just very briefly, right, I'm Christo Wilson. I like to keep these talks interactive, so please feel free to ping me in the chat if you have questions, and I'll try to stop and address them as we go. So I'm a computer scientist at Northeastern. I got my PhD in 2012 with Ben Zhao, who's now at University of Chicago. And although I sit in the Cybersecurity and Privacy Institute here, I'm a bit of an anomaly. So my primary tools of the trade are really measurement and observation. I consider myself to be an empiricist. So, in terms of what I apply this lens to, some of my work, I guess you could consider to be within the classical security and privacy domain. So things like measuring public key infrastructures and looking at online privacy and tracking and smartphone tracking. But the other major area of my research is looking at the black box systems deployed by major online platforms. So broadly, this is something that we call algorithm auditing. So I'll set the stage a little bit, and many of you have probably heard this before because there's many people at Michigan who are intimately aware of this area and contributing to it. But just in case you're coming at this from the outside, the motivating problem for today, for today's talk, is that social and structural bias is getting coded into data sets. So this idea that data is kind of a neutral snapshot of the world is really a fallacy. There's any number of ways that bias that's present in the real world gets embedded into our data sets. And then we do things with that data. We train algorithms, we deploy them, and then those systems go on to reproduce and entrench those biases. So there's increasing concern about these issues as more big data systems and machine learning get applied into real world scenarios. There's certainly concern among the academic community. Investigative journalists like Julia Angwin are really pioneers in this area. There's some interest by regulators and certainly by people, the users who use these systems and notice a lot of these problems. So the question that really motivates my work is, how do we actually go out and look for these problems in the real world? It's all well and good to acknowledge that the problems may exist in the hypothetical sense, and we can talk about ways to try and regulate these issues. But arguably, if we don't know what's happening, it's hard to inform policy, and it's even harder to do enforcement, right? You can make all the rules you want, but if we don't know what systems are actually doing in the real world, these laws are largely toothless. So, these algorithms that we're talking about are typically trade secrets. No one's revealing the source code, and they're highly dynamic. They're changing all the time. Even if you somehow demanded that all these things be open source, that's not enough, because we're talking about data-driven systems. Arguably, you'd also want to inspect the data to see where it came from. Are there any latent issues? And obviously, you're not going to demand that all this data become public, because that would be a privacy nightmare. So what are we left to do? Well, I would argue that this is where algorithm auditing comes into play. So Andy Sellers over at BU likes to refer to the work that I do and my colleagues and people like Christian Sandvig as permissionless testing. So we're going out and doing some light reverse engineering of people's systems to understand how they work, what kind of data they're collecting, and how those inputs end up affecting the outputs of the system, and if there are problems, and what that really means for people who use those systems. So we've done a lot of work on this in the past, looking at systems like Google Search, surge pricing on Uber and Lyft, different algorithms in Amazon Marketplace. So, all different kinds of systems with all different kinds of problems. But today, what I want to focus on are hiring websites. So for those of you who are students, you've probably encountered a lot of these platforms. You go and you post your resume, you hope that recruiters contact you, or you go and you look at jobs that companies are posting and you apply. So, websites like this are super popular. Monster and Indeed, LinkedIn, Glassdoor, they have millions of users and tens to hundreds of thousands of companies that use these platforms as a way to match candidates to the jobs they're trying to fill positions. So these platforms really have two sides. One is kind of the user or individual facing side, where you're uploading your resume and you're browsing jobs. But then there's also the recruiting side. If you're a recruiter, you can go on these websites and search for people. You browse their resumes and you try to find candidates for open positions, or you find people with valuable skills and you try to poach them. So that's really the facet of this that we're going to be focusing on, is this resume and kind of recruiter side. So in case you've never used one of these tools from the perspective of a recruiter, I can show you what this looks like. Here's what happens on Indeed. If you go and search for a software engineer who's based in kind of the New York area. This is a little bit old. The interface has changed a little bit, but it's still roughly representative. So you enter your query. In the left-hand rail, you can refine the query like any good search engine. And in the middle, you get this list of people. These are the people that the system believes match your query and that you should go out and potentially recruit and headhunt. So, you've got your query, you've got your filters, you've got these people. And the interesting thing about this is that it doesn't really say how these people are being sorted. Like most search engines, the ranking algorithm itself is opaque. It just says they're rated by relevance. That's sort of a weasel word. It doesn't really mean anything. What does it mean for this particular software engineer to be more relevant than another? Is it their experience or their education? You just don't know. And problematically, you don't know if there are any demographic features that are being used or that are potentially influencing the ranking based on some kind of proxy effect. You just don't know what the ranking is or why it's being produced. And that's potentially disturbing. If there is demographic information sneaking into the algorithm, does that mean you're going to end up with a situation where people in particular groups are systematically being rated or ranked higher than people from other groups? So you'll notice that these sites typically don't collect a lot of demographic information. If you upload your resume, you typically don't say, if you're a man or a woman, where you came from or anything like that. And here, the only thing that really identifies these individuals are their names. You don't have profile photos or anything like that. So on one hand, the platform designers are making an attempt to not collect sensitive information or present it, hopefully to make it so that recruiters won't have, biased decisions. But we know that the real world is not that simple. People are uploading rich data about themselves in their form of resumes, they're filling out personal profiles. There's any number of ways that that data could correlate with protected groups, protected class attributes, which then might influence the ranking algorithm. So this gets into this question of hiring discrimination. Hiring discrimination is a long-standing problem. This is the reason why things like the Equal Opportunity Employment Commission exist, to try and eliminate hiring discrimination. And we know that people have biases. Recruiters have explicit or latent biases, and that's a problem. So you could argue, maybe we should have more automation. In theory, if you designed a system well enough and you checked it for bias, you made sure there was no demographic information getting inside of it, maybe that would be better than human recruiters. Maybe that would result in decisions that were less biased. But unfortunately, the real world is not that simple. So, if there were to be demographic information sneaking into the algorithm that happened to correlate, with any of the features in the resumes, for example, that's going to result in a ranking that is biased. And that can result in recruiters spending more of their attention looking at particular groups. If we look at the results of eye tracking studies, let's say, of something like Google search, we know that people don't consume ranked information uniformly. Their attention tends to be focused on the top results. So again, if there is any sort of link between rank and demographics, that could lead to tangible harms. People from certain groups getting hired and interviewed more frequently, that's a serious problem. It's depriving people from the disadvantaged group from opportunity. So if you're wondering, well, has this ever happened in the past, or is this just hypothetical? There have been documented cases of these kinds of bias issues creeping into hiring platforms. So many years ago, we did a study where we looked at some gig economy services. This is TaskRabbit. And we found two things. One was that the feedback that these workers was getting was very much linked to their demographics. White men got higher star ratings and better reviews than women and people of color. And then unfortunately, we found that the search algorithm was taking that social feedback into account. So you'd go to TaskRabbit and you'd say, I want to hire a dog walker. Well, how are they sorted? They're sorted by the star rating. Unfortunately, that star rating data had biases, which meant the search engine then had biases. Another example from the popular press, Amazon apparently developed this artificial intelligence tool to help them recruit. But unfortunately, it was trained on all their historical data, which was highly gender unbalanced, and it resulted in a system that preferred hiring men. So Amazon, scrapped this system, but I don't think we really know how long it was actually in production use. And of course, that's terrible, right? So this brings me to the goals of the study that we did. So our goal was to look at gender-based inequality in the ranking algorithms used by a couple of the major hiring sites. So we looked at Indeed, Monster, and Career Builder. And when we did the study, we looked at two different definitions of fairness. So those of you who are steeped in this literature know this problem well. We don't agree on what it means to be fair, and not all of these definitions are compatible. So we looked at two different kinds of fairness. The first was individual fairness, which you can roughly conceptualize as equal opportunity. So two people with the same characteristics, like years of experience, alma mater, etc., they should appear at the same ranks. And that should happen regardless of gender. The second kind of fairness we look at is group fairness. So this is different. This is saying that if you have 100 candidates who are viable, and 50% of them are men and 50% of them are women, in the results, you really expect the men and the women to be interleaved. So in other words, the average rank of men should be equal to the average rank of women. And that's happening regardless of qualification, right? This is just saying the groups should have equal exposure in the search rankings. So the third facet of the study was, if we find that gender does have an impact on rank, the question is why? Is this a result of direct or indirect discrimination? So by that, what I mean is the ranking algorithm taking in gender as a feature explicitly and using that to rank people, right? That would be direct discrimination. Or is this some kind of latent or proxy effect where the algorithm is, it's finding correlations with gender? So I'll walk you through kind of the study that we did. I'll start by talking about kind of the data we collected. I'll talk about how we measured individual and group fairness. I'll talk about whether we found direct discrimination. And then we'll conclude with sort of some final thoughts and some discussion points around the study. So this is an audit. We typically conceptualize these as, the same way that you would a classic audit study from the social sciences. So our experimental subjects are the platforms, right? We're studying Indeed, Monster, and Career Builder. We chose them because they're some of the most popular employment sites in the US. LinkedIn is actually larger, but we didn't study them because, one, it's very expensive to get recruiter accounts, and two, they are known to be very litigious, and we did not want to be sued into oblivion. So for Monster and Career Builder, if you want access to the recruiter tools, you have to pay money. So we signed up as a recruiter. It's a couple $100 a month. For Indeed, the recruiter tool is public. So I don't even think you need to make an account. You can just access it directly. And so then the data we need for our study are search results. Lots and lots of search results from these services. And ideally, we would like these search results to be diverse in terms of the professions we're looking at, as well as the locations, because we know that the populations and the dynamics of hiring and employment are just not uniform throughout the country. So in terms of getting query diversity, we ran queries from 20 different cities in the US, distributed such that they cover kind of the major metropolitan areas, as well as more suburban and rural areas to give us a little bit of diversity. And then in terms of job titles, so in every city we ran queries for 35 different job titles. And these were drawn from some of the EEOC's classifications of job types. So some of these corresponded to high skill jobs, things like software, network, and electrical engineers, jobs that require certification like physical therapists, and things like accountants. And then we matched that with a bunch of other job titles for low skill jobs. So things like laborers, truck drivers, taxi drivers, customer service. Again, because we want a lot of diversity here. It can't just be jobs that require degrees, high level degrees. We really want kind of a broad swath of the employment landscape. So we ran all of these queries, in all these locations across all three services. And then actually we did it a couple more times because we changed the search filters. So we ended up running hundreds of thousands of queries over the course of a couple months. So we didn't break the rate limits on the sites. So in terms of the data that we're getting from the sites, they're all a little bit different in terms of the information they present about the candidates. But I can sort of tell you at a high level what features we got from the different services. So in pretty much all these cases, we get basic profile information like the job title. So if the person's currently employed, what is their job title and what are the skills that they've said they hold? Things like years of experience and education level. We also get recency information. So when did they upload their resume? Is it stale or is it fresh? On Monster and Career Builder, there's a limit to how many resumes you can look at per month, and it's very low. You can only look at tens of resumes. So we didn't bother, given that we were looking at hundreds of thousands of queries. But on Indeed, you can see the resumes. So on Indeed, we did get the full resume for everyone. And we can parse that to pull out more biographical information. So in total, on Indeed and Monster, we got 13 features per candidate. And then on Career Builder, there were less features available. There were only 6. What you'll notice is that this is sort of a theme. The amount of data and the quality of the data on Career Builder was lower than the other sites. It's just a smaller platform that's not as rich. So this is, a good starting place. We've got our queries, we've got data per candidate, we have lots of samples, but I'm missing kind of the key element of the study, which is gender. The whole point here was to look at whether the rankings are biased based on gender, and the sites don't provide that. None of them even collect it. So the question is, well, where am I going to get that data so I can look at the correlations between gender and rank? So this is, a serious problem. Really, the only way to get people's gender would be to ask them. It's not something that you can just infer based on, observed information. That's not fair at all. So instead, what we did is we sort of moved the goalpost. If you think about this system from the perspective of a recruiter, or even like a biased recruiter, what are they going to do? Well, they're looking at the results, they're looking at the individuals, and they can see their names. At least in Western societies, names tend to be gendered. So a recruiter might look at a particular name and try to infer, well, this is a man or this is a woman. And that might trigger explicit or implicit biases. So we can do the same thing. So what we did is we looked at the names of all the people in the search results. We used that to infer masculinity. So do we think this is a masculine person or a feminine person? And we do this based on the US baby name data set. So this is all public information about the names of children born in this country. So the graph I'm showing here is the results of the inference. So for every candidate we observed, we infer a probability of being masculine based on how that name has been used to assign names to children at birth. So the x-axis here is the probability of being masculine for all candidates, and the y-axis is CDF. And then we got 3 lines corresponding to our 3 services. So if we just focus on the tails of the distribution, we see that most of our candidates have a highly gendered name. So it's easy to say, this person is at least likely to be perceived as masculine or likely to be perceived as feminine. These are names with obvious gender connotations like Christopher. In the middle is there's some ambiguity. So there's around 8% of the population where we can't really say one way or the other. Many of these names are actually people who don't have Western names. In particular, things like Chinese names are not gendered. So we can't really say anything about these candidates. But in general, we have pretty good confidence in these inferences, at least in terms of how a recruiter would look at them and what kind of biases that would activate in a recruiter just reading names. So to summarize the data set, we ran queries for 35 job titles in 20 cities. Per query, we're looking at the top 1,000 candidates in that city. So it's a lot of data. The queries and the data were all collected between May and October of 2016. So then in total, we had around 500,000 unique candidates we saw on Indeed, 265,000 on Monster, and then 68,000 on Career Builder. So as I mentioned, Career Builder is the smallest of the three platforms by far. So just a brief note on the ethics of this study. It was IRB approved, and we did take steps to make sure that we were limiting our impact on the websites. So we were only running one query every 30 seconds. So, I mean, we did do this for months, but at any given moment, the load impact of what we were doing is negligible. Because this is personal data with people's names, we're not releasing any of it publicly, and we don't want to violate people's contextual sense of privacy. They uploaded that data for a purpose, not for research. So it would not be okay for us to just distribute it. Finally, we didn't interact with any people through these services. We didn't contact candidates. We didn't contact recruiters. So we were essentially invisible to the people using those services. Okay, so now let's move on to kind of the meat of the study, looking at individual and group fairness. So we really had kind of two research questions that we were focused on. Now, the first is, are the search engines individually fair with respect to gender, or at least this inference of masculinity that we're making? So our definition here is placing candidates with similar features, excluding gender, at similar ranks, which roughly maps to equal opportunity. All right, our second research question is about group fairness. Are the search engines group fair with respect to gender? So our operating definition here is assigning similar distributions of ranks to men and women, and this can roughly be operationalized as disparate impact. If the average rank for men is significantly higher or significantly lower than the average rank for women, I think you could make a compelling case that that was likely to cause disparate impact. All right, the final question that we'll get to is this direct discrimination. If we see a problem, can we say anything about why that might be happening? So we'll start with the individual fairness question. And the tool we're going to use to analyze this is regression. So we're going to be putting all the features into a model and looking at whether there are correlations to the inferred masculinity. So our dependent variable here is the log of participants' rank. So log is really important here because it sort of accounts for the decay in attention as you go down the list. Log transforming data is pretty much standard in the information retrieval community. So the question is, what's the right regression model to use in this case? So if we think about using something like ordinary least squares, it's just a baseline. You might conceptualize that as a model where you have the log of rank, and that's then a combination of the feature values, the feature weights, and some error terms. But this has some unfortunate assumptions built into it, right? It's assuming that for these feature weights, these are going to be the same for every job title and location. So maybe that's okay, but it's not ideal. So we can look at an example of why this might be problematic. Let's say that we're looking for software engineers in San Francisco and New York. If we got results that looked like this, so each box here has the rank of the candidate, and then I've color coded them based on relevance. So the green candidates are the most relevant. If you put this into a model, I think the results that you get out would be okay. looking at the paired candidates, for the most part, the salience of the candidates matches. There's some mismatches, like at rank number 3, where one candidate is qualified and the other's sort of not qualified. But for the most part, the data is sort of nicely paired. The problem is that our data is extremely heterogeneous. So imagine that you're comparing software engineers in California versus like Mobile, Alabama, where you just wouldn't expect to find strong software engineers. What you're going to see is that the paired candidates at any given rank have wildly different qualifications. And this is very confusing for the model, right? It's trying to infer, what are the features that matter at, say, rank 1, but you have people that have wildly different features and wildly different correlations. So these, this just doesn't match as you start doing the pairwise comparisons. So, this kind of naive OLS model just can't handle this kind of heterogeneity. It's not ideal for this kind of data. So the way we get around this is we adopt a mixed linear model instead of OLS. So this is essentially having random effects attributes added to the model. So different intercepts for different job titles and different cities. So in other words, it's trying to take into account the fact that different jobs are going to have different characteristics and different physical locations will have different characteristics. So you can sort of visualize what this does to the data. The random effects intercepts are essentially adding offsets, where rather than compare the ranks as given, you're essentially shifting data over to find the point where there's a greater overlap in terms of the people's qualifications. Right? By adding that random effect, you're accounting for the fact that there are just stronger software engineers in this case in San Francisco, and you're realigning it so that it's the candidates who are paired with other candidates who are like them. Okay, so that was how we set up our model. We've got log rank as the dependent variable. We're using a mixed linear regression. So all of our candidate features are going into the models, and then we're training the random effects to deal with these kind of heterogeneities across job titles and locations. So I can show you kind of the key results from these regressions. So what we're looking at here is the relationship between the probability of being masculine that the models found versus log rank. So the x-axis here is rank, and then the y-axis is the rank increase experienced by men or candidates who we inferred to be masculine. So this is really focusing on kind of the effect of what we found. So we did find across all the services under a variety of conditions that the probability of masculine did have a statistically significant relationship with log rank. But the question is the effect size meaningful? So if we look at the candidates that are appearing at the top ranks, let's say the top 10 down to about the top 50, the practical impact or the effect size of the probability of being masculine is essentially negligible. If you look at the y-axis there, the amount that it's increasing the ranks for men is less than 1 rank. So, we have a lot of data, which means it's easy to find statistically significant effects. But in terms of whether it has a practical impact on the search results, at least if recruiters are just looking at top results, it doesn't seem like it has a huge impact. Now, that said, if recruiters are looking at lots of candidates, like let's say the top 100, all of a sudden the effect size does start to matter. So by the time you've gotten down to rank 50 and below, what you see is that a man or a masculine candidate and a feminine candidate who have equal qualifications, the tie will be consistently broken in favor of the masculine candidate. So, the feminine candidate gets pushed down 1 or 2 ranks. Maybe that doesn't sound terrible, But when you start to consider that these results are paginated, so being pushed down a few ranks could mean that you appear on the next page, that starts to have a substantive impact. If the recruiter doesn't click through to that next page, you're going to miss someone. So the takeaway here is that we're seeing some unfairness linked to gender, but the effect size is not that great. And whether it actually matters in practice, we don't really understand, because we don't have any kind of ecological understanding of how recruiters actually use these services, how deep they go into the results. So we can switch gears at this point and talk about I just got an error about the microphone. Are people hearing me okay?
I can hear you just fine.
Okay, awesome, thank you. So we're switching to group fairness now. So this is essentially asking, is the average rank of the masculine candidates similar to the average rank of the feminine candidates? So for here, what we're going to be doing is, standard statistical testing using Mann-Whitney-U tests. So we're looking at the distributions of rank for the masculine candidates and the feminine candidates, and we're asking, are those distributions significantly different? So what I'm highlighting in the table here is just looking at cases where, for the different services, in aggregate, how many of these job titles were there where we saw a statistically significant difference between the two distributions? So overall, across Indeed, Monster, and Career Builder, most of the job titles, we don't see statistically significant differences between the distributions. Like on Indeed, for example, only 13% of the job titles had these statistically significant differences. So on one hand, that seems better than I perhaps would have expected going into this project. 10% having these differences and not being group fair, it could be a lot worse. But there's some disquieting results hidden in there. So if we look at which group is advantaged in all these cases where the distributions were different, it was always more favorable to men. So in all those cases, the male candidates were appearing at higher ranks, which is disturbing. And then if we dig into the specific job titles where we saw these statistically significant differences, there's some disturbing stuff in here. So across the services, we consistently saw that like electrical engineering, mechanical engineering, network engineering, software engineering, those were all job titles where men were appearing at significantly higher ranks than women. And that's taking into account the fact that just at the baseline, the candidate population is unequal. For something like software engineers, I want to say that about somewhere like 60 to 80% of the candidates we were inferring to be men. So even taking that into account, that the population is unequal, we're still seeing these disparities, which is really disturbing. We know that there's these systemic kind of gender inequality issues in engineering fields, and we're seeing it here when we're looking at these search engines, pushing the male candidates to the tops of the list. That's not good, in my opinion. So we'll move on to our third research question, which is looking at direct discrimination. So just to refresh your memory, these sites are not soliciting gender. When you make a profile, they don't ask your gender. People aren't adding gender to their resumes. I mean, they could, but we don't observe anyone doing that, and I don't know why anyone would. So the question is, how do they end up with a search engine that exhibits these kinds of gender bias if they're not collecting the data? So the issue is going to be potentially proxies. Are there things in the data that are correlated with gender and then cause the algorithm to rank men at a higher position, even though they weren't trained specifically with gender as a feature, or maybe they were trained with gender as a feature? So to get at this question of direct discrimination, is the algorithm using gender as a feature, or is it something latent, the cause? We went back to the services and ran controlled experiments. So what we did is we uploaded resumes and we varied the names of the candidates to see what would happen. So here's a toy example. We would pick a particular job category. We would upload 2 resumes with stereotypically masculine names like Joe and Bob. And then we would search and see where our resumes appeared, and we would record the order. Right, then we would modify one of those resumes to change the name. Right, so we change Bob to Amy, and then we would look to see, does that have an impact on the rank? So if we see that the rank is unchanged, that suggests that changing the name didn't have any impact. The algorithm was not reading the name out and doing gender inference. So gender is unlikely to be a feature, and there's no direct discrimination. Alternatively, if we upload that resume with the feminine name and all of a sudden the results flip, that's strongly suggestive of the name actually being used as a variable in the model, meaning that there is direct discrimination going on. So we uploaded resumes that had a bunch of different controlled features. So that, the big one was the names for inferred gender. And what you're seeing here with those red X's in the table is that that feature didn't matter, in the sense that when we uploaded those resumes and we changed the name, their position and the order did not change, which strongly suggests that the names are not being extracted by the algorithms and used as features for ranking. You'll see that most of these boxes are red X's. So we tried things like changing the keywords in the resumes, changing the length of the resume, changing the company name where you currently worked, and none of those had an effect. But there are a couple of green check marks in there, and those are cases where changing that field of the resume did have a substantive impact on rank. So for example, on Monster, it turned out that they are actually extracting your school where you got your degrees, and they're extracting whether you are currently employed or not, and those are being used as features in the ranking. Now, that's really interesting because neither of those questions are asked when you set up a profile, right? They're not something that you explicitly divulge, but it's absolutely being extracted because we can see it in the controlled tests. It didn't look like Indeed was doing any extraction, but both Monster and Career Builder were both extracting features that they didn't reveal anywhere. But the main point for us was really just that there's no direct discrimination going on here. They're not extracting people's names. They're not doing gender inference on those names. So what that suggests is these effects that we're seeing are almost certainly due to proxies. It's things like years of experience and job title, that unfortunately, have correlations with gender because of a discrimination in the workplace. That affects resumes, which then affects rank that people appear at in these sites. So just to briefly conclude, I got a question online. Were any of the red crosses used as questions when filling the profile? My recollection is that they were not. If we rewind a little bit. I don't think any of them were. So for example, with school, the profile would ask, what level of degree have you obtained? So you'd say, I have a PhD or I have a high school diploma or whatever, but they didn't ask for your alma mater, like where the degrees came from. But they clearly were checking from the resume because we could like swap a Harvard for a community college and it mattered. Things like job churn, it's the same kind of thing. They'll ask if you're currently employed, but not your complete employment history. But we could see that if you added lots of employment history to the resume, that had an impact. Maybe it looks like you're a bad employee because you keep switching jobs.
Hey, Christo, I don't know if you want to take questions now, but there is a question in the Q&A tab at the bottom of your screen, which you're welcome to defer to the end if that's how you'd like to handle it or take it.
Oh, I totally missed that. I was just looking at the chat. Thank you for that heads up. Question online in the Q&A. For the graph with the masculine advantage and rank by the 3 different sites, was this broken down by something like skilled versus unskilled or by industry? So you're talking about, I think this is referring to individual, the individual fairness question. So that graph was not broken down by particular skill or industry. In the paper, we did look at this. I mean, we must have run a gazillion models looking at just particular industries or locations. We looked at results with and without search filters. So we would add filters like minimum years of experience, minimum degree requirements, distance to the job. We did a bunch of other things looking at propensity matched models, so we would just whittle it down to all the candidates that were actually, kind of equal and comparable. And almost uniformly across all these models, the answer was always the same. The gender coefficient was statistically significant, but the effect size was always very small. Another question online. Do you think there is a possibility of using a model that is different from the mixed random effects model for this use case? Yeah, I mean, so I think the hierarchical model was, I think that was probably the ideal model, given what we talked to a bunch of people who do kind of labor economy work. And they suggested that this was the right thing to do, given the heterogeneity of the job market. But yeah, I don't know, actually. Yeah, it's a good question. So yeah, just to briefly conclude before we get into the rest of the Q&A, there's a bunch of very important limitations to acknowledge of this study. One thing that you've undoubtedly noticed is that we're talking about inferred genders, and this was binary, and obviously this is a huge problem. The right way to do this would be to actually ask people and get ground truth information. And to have a much more nuanced understanding of gender and to really explode that. Unfortunately, this is a study of convenience in the sense that we did the best using what was available. The right way to do it would be to actually go and contact all these candidates and use a bunch of qualitative methods. But trying to do this at scale is super challenging. So there's some questions here about ecological validity. Where we generated these search queries, we chose the filters and the locations. We don't know if these are representative of the queries that actual recruiters use. There's just no good data on this. Furthermore, we don't know how recruiters really use the search engines. Do they look at the top 10 results? Do they look at the top 500 results? We just don't know. And that makes it a little bit difficult to contextualize our findings. One unsatisfying thing about the study is that we can't really explain why we're seeing this unfairness. We are pretty confident that there's no direct discrimination, but what is it about the data and the proxies embedded in that data that cause the unfairness? We can't say for sure because we don't know all the features that are being extracted from the resumes. We did the best controlled experiments we could, but they're definitely not comprehensive. So just to wrap up, I'm pretty confident in saying there's no direct discrimination on these sites. At least when we did our study, we didn't see it. In terms of individual fairness, we did see statistically significant correlations to inferred gender, but the effect size was small. So how you feel about that, it really depends on how we think recruiters are using the sites, and perhaps from a normative standpoint, whether these algorithms should be designed explicitly to eliminate gender bias, rather than just kind of let it not be a big deal naturally, which I think is probably what's happening here. With respect to group fairness, I don't think group unfairness is like endemic on these sites. We see it in anywhere from 8 to 13% of the job titles we looked at. That's not terrible, but it's also not great, especially when you consider that it was always advantaging men, and a lot of it was clustered in either low-wage jobs or engineering jobs, where we already know there are gender bias problems. And it looks like the ranking algorithms are just reinforcing this. So I guess I'll leave it there. There's lots of interesting kind of discussion points that come out of this. Do we think that these kinds of services should be more explicit in terms of trying to de-bias their systems? Are we okay with the kind of data they would have to collect in order to do that? If we say we think they should be fair, fair how? Is it individual? Is it group? Is it something between? And then, there's questions about kind of algorithm auditing as a practice. Is this something that we think people should be doing? The platforms are obviously, they have different feelings about people like me looking at their stuff without their knowledge. So, does the social benefit of this outweigh some of the costs? Should we mandate this? I have strong opinions on all these things, but I'm interested in hearing from the audience. What do you think about this stuff? I don't know how this usually works. Do I moderate questions?
Totally up to you. I'm happy to step in to the extent that it's helpful. But basically, since it's on the web, you're going to see questions both in the Q&A tab, and I think some people also post it in the chat. I'll help you to the extent you need help, but just go for it.
Okay. So yeah, interesting comment in chat, trying to combat bias with some point in between group and individual. I guess I'm of two minds on that. On one hand, I understand the intuitive appeal. If we can't have both, trying to balance the two seems reasonable. In some sense, I think that's trying to balance the two is perhaps feasible under current law. If you look at like the EEOC recommendations, the law of the land is the 4/5 rule, so that the outcomes for different groups shouldn't be more than 20%. And 20% actually gives you a fair amount of leeway if you want to try and balance individual and group fairness. So maybe that's fine. On the other hand, it's somewhat unsatisfying to say, well, it's not really individually fair and it's not really group fair. It's this mishy-mashy place in the middle. The other point I'll make is that I'm increasingly I don't like individual fairness as a concept. I sort of think that it rests on a false sense of quantification and objectification. We're talking about hiring, and is someone who has 12 years of experience, should they really be at rank 1 versus someone who has 9 years of experience? It's not really clear how to quantify that. And once you start adding in more and more features, what does it mean to really be the best or qualified? So if we're saying, this is individually fair and the best people are showing up at the top, that already embeds all these assumptions about what is best and how to quantify these human characteristics. And I don't think there's principled ways to do that in a lot of cases. We think we're being objective and that we're being individually fair, but you can change all those assumptions and turn the knobs a different way, and we can claim the same thing, but the outcomes are different. So given this, a society where we know there's inequality, I'm pretty liberal. I think we really should be tuning things more for group fairness, at least until we've addressed systemic racism and sexism. But again, that's just me on my soapbox.
We have a couple of minutes if people have more questions. Okay, here we got some in the chat.
Yeah, so from working at a tech company, I know rank can also change from the percentage of times it's clicked. Yes, absolutely. Some boost like this might be difficult to quantify. So this was a huge concern when we ran this study. We knew that, or we suspected that clicks might influence the rank. So when we were collecting the data, we were constantly re-crawling to try and get at that exact moment when like our resumes would get posted, because we didn't want them to sit there for a long time and get a bunch of clicks and have that affect the rankings. We didn't want that to be a confound, essentially, in our controlled experiments. So then with respect to the observational stuff where we're seeing that men were appearing at slightly higher ranks, I think you're absolutely right that this is potentially one reason why we're seeing that. It could very well be that recruiters are biased and they tend to click on men, especially in these job scenarios for like software engineers. So either those individuals getting the clicks are moving up, or the algorithm is learning something latent in general if it's doing like online learning, which again has the same effect that the click data is now embedding kind of this recruiter bias in. I'd love to go back and do another study on this. We just have to think very carefully about how to do that, because now we're talking about uploading things and then generating lots of clicks on them, and now we're polluting data sets, and I don't want to attack the system or trigger the security apparatus. So it's a challenging audit to run. But yeah, I mean, I'd love to know if that data is being collected and how it's being used in these systems. Another comment online, will people be amenable to this if they are aware of what data is being collected? Companies may not be comfortable with sharing the data. Yeah, I mean, this is a really complex question. If you went on a hiring site and you were making an account and the first thing they said is, please give us detailed demographic information, and we promise that we won't share it with companies and we're only going to use it to de-bias our algorithms, would you trust them? We're talking about sensitive characteristics here, and it's a context where we know that there's historic inequity. So, I mean, like maybe I would be comfortable doing that, but I'm also like a white straight dude. I'm not the negatively impacted group here. If we're talking about people who know they're going to be, or suspect they may be disadvantaged, I don't know if they'd be willing to divulge that information. We can also think about contexts like banking, where you're actually not allowed to collect that data. Again, because of how it was used in the past for things like redlining. Even if you want to make the thing fair, you just aren't allowed to collect that data. And then banks do silly things like try to infer demographics and use the inferred data for fairness testing, which is really absurd. But yeah, I mean, there's a social change element here, getting people comfortable with the idea that divulging this information is okay and in their own interest, and then a law and policy side about how if someone's going to collect that data, it has to be used in a beneficial way to users. It can only be used for that purpose. It can't be shared. Because otherwise, what will happen. The data will be used for other purposes that may disadvantage people, which is the exact opposite of what we're going for here.
So, Christo, we're right at 5. We got that was a fantastic talk. I think you made a bunch of people think, which is great. I really appreciate your taking the time to spend some hours with us today. Appreciate it very much.
It was my pleasure. Thank you for having me. And thank you for all sticking around late to hear me blab.
Well, hope to interact with you more down the road. Thank you.
Definitely.
And thank you everybody for coming.
Thank you, everybody.
Bye-bye, and see you next week at the symposium.